Hello everyone. Today we'll review for exam 3. First problem. In a college, students' score of their entrance exam are normally distributed with a mean of 110 out of 160 and a standard deviation of 12.5. Part A. What percent of students have their entrance exam score between 90 and 100? Part B. What percent of students have their entrance exam score below 105? Part C. What's the cutoff of the lowest 20% exam scores? Part D. What's the range for the middle 28% exam scores? First of all, let's set down the problems. Let's set down the problem first. First of all, the X represents a student's entrance exam score. Then the random variable X represents a student's entrance exam score. Then, since the entrance exam scores are normally distributed, we know that X has a normal distribution with a mean of 110. X has a normal distribution with a mean of 110. Variance is 12.5 squared, since standard deviation is 12.5. Variance is 12.5 squared. So X has a normal distribution. Now, based on this, let's answer the first question. Part A. What percent of students have their entrance exam score between 90 and 100? We're looking for the probability that X is between 90 and 100. We're looking for the probability that X is between 90 and 100. If we don't specify an endpoint, usually we include an endpoint, include 90 and 100. If we don't specify an endpoint, usually we include the endpoint 90 and 100. Then X has a normal distribution. If we try to solve it directly, by taking integral of the PDF, it may be too complicated. 2 pi times sigma. Sigma is 12.5 times e raised to negative x minus mu. Mu is 110. S minus mu squared over 2 times sigma squared. If we try to solve this integral, it may be too complicated. If we try to solve this integral directly, it may be too complicated. A simple rule is we can try to use the standard normal CDF. We can try to use the standard normal CDF to find integral, to find a probability. So let's use the standard normal CDF. If we try to use the standard normal CDF, we must convert X to Z. We must convert X to the standard normal distribution. So convert X to Z. The formula for conversion is Z equal to X minus mu over sigma. So we take 90 minus mu over sigma. 100 minus mu over sigma. Then use calculator. 90 minus 110 over 12.5. I get negative 1.6 in my calculator. Round to two decimal places, that's 1.60. 100 minus 110 over 12.5. If I use my calculator, I get negative 0.8. If I round to two decimal places, I get negative 0.80. Next, in order to use the CDF to find probabilities, I must run the probability in the form of probability that Z less or equal to some constant, or probability that Z less than some constant. They both equal to phi of Z. So we try to do the equation, we run probability in this form first. So this probability can be rewritten as probability that Z less or equal to negative 0.80 minus probability that Z is less than negative 1.60. Then That's phi of negative 0.80. This is phi of negative 1.60. Then using the standard normal CDF find the probability. Using the standard normal CDF find the probability. That's the table of the standard normal CDF. That's the table of the standard normal cumulative distribution function, phi of z. So for phi of negative 80, negative 0.8 is here. Phi of negative 80 is here. That's 0.21186. That's 0.21186. 0.21186. For phi of negative 1.60. For phi of negative 1.60, it's here, 0.05480. 0.05480. 0.05480. Then subtract. If I use my calculator and subtract here, I have 0.15706. If I round the answer to 4 decimal places, it's 0.1571. Then if I change the number to percent, it's 15.71%. That means 15.71% of students have their entrance exam score between 90 and 100. That's part A. Part B, what percent of students have their entrance exam score below 105? So for part B, we're looking for probability that x is less than 105. So similarly, we can convert x to the standard normal distribution, then use the table of the standard normal CDF to find probability. Let's first of all convert x to z. The formula for conversion is x minus mu over sigma. Mu is 110 here. Sigma is 12.5. Then use calculator. I get negative 0.4. That's phi of negative 0.40. If I round to 2 decimal places, that's negative 0.40. Then use table. Phi of negative 0.40 in the table. Negative 0.4 is here. Zero is here. Negative 0.40 is 0.34458. 0.34458. If we round the answer to two decimal places, that's 0.3446. And then we're looking for percentage. So convert this number to percent. It's about 34.46%. So 34.46% of students have an exam score, have an entrance exam score below 105. That's part B. Part C. What's the cutoff for the lowest 20% exam scores? We know that the graph of the PDF of a normal distribution must be an upside down bell-shaped curve. The graph of the PDF of a normal distribution is upside down bell-shaped curve. And that's the lowest 20%. We're looking for the cutoff here. If this is the standard normal distribution, it will be 0 in the middle. And z is here. We're looking for, let's find z first. So we're looking for a z. Such that probability that z less than z equal to 20%. Let's find z first. This is phi of z. Equal to 20%. 20% is 0.2000. Then use the table of the standard normal CDF, we can find z. Let's look at the table of the standard normal CDF. Find the closest number to 0.20000 in the table. in the table, the closest number to 0.20000 is this number here, 0.2000045. That's the closest number in the table. And the corresponding z-score here, the corresponding z-score is negative 0.8, negative 0.84. The corresponding z-score is negative 0.84. We know that the conversion from x to z is z equal to s minus mu over sigma. If we try to change z back to x is mu plus z times sigma. S is mu plus z times sigma. So we change z back to x. X is mu plus z times sigma. Sigma is 12.5. (110 minus 0.84 times 12.5). Then use calculator, I get 99.5. So 99.5 is the cutoff for the lowest 20% exam scores. That's part C. Part D. What's the range for the middle 28% exam scores? We know that the graph of the PDF of a normal distribution is always an upside down bell-shaped curve. That's the graph of the PDF of a normal distribution. That's the middle 28% exam scores. That's the middle 28% exam scores. If this is the standard normal distribution, then it will be 0 in the middle. The graph is symmetrical at 0. So that's negative z, that's positive z. The total probability is always 1. If we have 28% here, then what's here, what's on the left and right is 1 minus 28%, which is 72%. Then if I take 72% divided by 2, I get 36%. That means the percentage of delta value on the left side is 36%. And the percentage of delta value on the right side is another 36%. Let's try to find z based on this percentage here. Let's try to find z based on the percentage here. We know that probability that z less or equal to negative z is 36%. Probability that z less or equal to negative z is 36%. That's phi of negative z. If I convert 36% to decimal number, that's 0.36000. Then use the table of the standard normal CDF. The closest number to 0.36000 in the table is this number here, 0.35942. That's the closest number to 0.36000. And the corresponding z-score here is negative 0.36. Negative 0.36. So negative z equal to negative 0.36. Then positive z will be positive 0.36. So that's the range, negative 0.36 and positive 0.36. Then we must convert z to x. The formula to convert z to x is x equal to mu plus z times sigma. So s equal to mu plus minus plus z times sigma. Mu is 110. Z is plus or minus 0.36. Z could be either positive or negative 0.36 times sigma. Sigma is 12.5. Then I use my calculator. S equal to 105.5 if z is negative. S equal to 114.5 if z is positive. That's the range. That's the range for the middle 28% exam scores. It's from 105.5 to 114.5. That's the range for the middle 28% exam scores. Number 2. When 4 coins are tossed, the X represents the number of heads, and the Y represents the position of the first head. If there are no heads, set Y equal to 5. Now, what does X and Y means? For example, if an outcome, when we toss 4 coins, if an outcome is head, tail, tail, head. What's X and Y here? X represents number of heads. There are 2 heads. Y represents the position of the first head. Y represents the position of the first head. That's the first head. It's in the first place, so the position is 1. Another case, if we have tail, head, head, head. What's X and Y? Here, X represents number of heads. There are 3 heads. Y represents the position of the first head. First head is here. It's in the second place, so Y is 2. Another example, tail, tail, head, head. X represents number of heads. Here, X is 2. Y represents the position of the first head. First head is here. It's in the third place, so Y equal to 3. So that's what S and Y means. That's what S and Y means. Number 2, part A. Find a joint probability function. In order to find a joint probability function, let's find the support of X and Y first. Usually you can write the joint probability function as a table. Let's find support of X and Y first. What's support of X? X represents number of heads. When we flip 4 coins, we may get 0 heads, 1 head, 2 heads, 3 heads, at most 4 heads. So support of X is 0, 1, 2, 3, 4. What's support of Y? Y represents the position of the first head. The first head could be in the first place, second place, third place, fourth place. Position could be in the first place, second place, third place, fourth place. If there are no heads, set Y equal to 5. So it's possible that Y could be 5. That's the support of X and Y. Then, based on the support of X and Y, draw a table. Usually we can use a table to represent joint probability function. Support of X is 0, 1, 2, 3, 4. Support of Y is 1, 2, 3, 4, 5. Let's find probability for each box. Let's find a probability for each box. First box, S is 0, Y is 1. S is 0 means there are no heads. There are no heads. Y is 1 means head appear in the first place. Y appear in the first position. That's impossible. If there are no heads, a head won't be in the first place. That's impossible. If there are no heads, heads won't be in the second place. If there are no heads, heads won't be in the third place. Heads won't be in the fourth place. And number 4 is a very special case. If there are no heads, we set Y equal to 5. If there are no heads, we set Y equal to 5. So in the situation of tail, 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 we have S equal to 0, Y equal to 5. And this is 1 out of what? when we flip 4 coins, each coin could be either head or tail. So the number of all possible outcomes is 2 to the power of 4. When we flip 4 coins, a coin could be either head or tails. So the number of all possible outcomes is 2 raised to the power of 4, which is 16. There's only one outcome here, so that's 1 out of 16. Second row, S is 1, Y is 1. That means there's only one head. And the first head appear in the first position. First head appear in the first place. There's only one head. And the first head appear in the first place. If there's only one head, first head appear in the first place. The only possibility is head, tail, tail, tail. That's 1 out of 16. If there's only one head, first head appear in the second place. The only possibility is tail, head, tail, tail. That's 1 out of 16. If there's only one head, the first head appear in the third place. It's also 1 out of 16. If there's only one head, a first head appear in the fourth place. That's 1 over 16. And if there's only one head, a head won't appear in the fifth place. That's 0. Next row. If there are 2 heads, x equal to 2 means that if there are 2 heads, what's the probability that the first head appear in the first place? If there are 2 heads, what's the probability that the first head appear in the first place? So if there are 2 heads, first head appear in the first place, then the second head could be second place, third place, or fourth place. There are 3 possibilities. Second head could be in the second place, third place, or fourth place. There are 3 possibilities. That's 3 out of 16. If there are 2 heads, first head appear in the second place. If there are 2 heads, first head appear in the second place. Then in the first place, it cannot be head, it must be tail. Then first head appear in the second place, it must be a head here. Then for the second head, it could be either here or here, since there are 2 heads. The second head could be either here or here. There are 2 possibilities. That's 2 over 16. Now, next. There are 2 heads. First head appear in the third place. If there are 2 heads, first head appear in the third place. If there are 2 heads, the first head appear in the third place. It must be tails in the first 2 places. And since there are 2 heads, the last place must be a head. There's only one possibility. That's 1 out of 16. If there are 2 heads, next box, there are 2 heads. First head appear in the fourth place. That sounds impossible. If the first head appear in the fourth place, it must be tails in the front. So it won't be 2 heads. That's impossible. And that's also impossible. First head won't be in the fifth place. S equals 3 means there are 3 heads. Y equal to 1 means first head appear in the first place. 1, 2, 3, 4. There are 3 heads. First head appear in the first place. Then for the other 2 heads, it could be head, head, tail, head, tail, head, tail, head, head. There are 3 possibilities. It could be head, head, tail, head, tail, head, or tail, head, head. There are 3 possibilities. That's 3 over 16. S equals 3, Y equals 2. If there are 3 heads, what's the probability that first head appear in the second place? 1, 2, 3, 4. If the first head appear in the second place, in the first place it must be a tail. And since there are 3 heads, the rest must be heads. There's only one possibility. That's 1 out of 16. Next, there are 3 heads. S equals 3, Y equals 3. There are 3 heads. first head appear in the third place. There are three heads. First head appear in the third place. If the first head appear in the first place, if the first head appear in the third place, it must be tail in the first two places. But if there are tails in the first two places, it won't be three heads. So that's impossible. Same thing, similarly, first head won't be in the fourth place. It won't be in the fifth place. That's impossible. Next row, x equal to 4. If there are 4 heads, first head appear in the first place. There are 4 heads, first head appear in the first place. If there are 4 heads, there's only one possibility. It must be all heads. And the first head must be in the first place. If there are 4 heads, there's only one possibility. And the first head must be in the first place. First head won't be in the second place. It won't be in the third place. In this situation, first head won't be in the second place. It won't be in the third place. It won't be in the fourth place. It won't be in the fifth place. Let's now join PDF. Part B. Find the marginal probability functions of x and y and determine whether the random variables x and y are independent. So let's find the marginal probability function for x and y first. For the marginal probability function of x, this is capital X, this is lowercase x. That's the marginal probability function of x. Here, since x and y, they are discrete random variables. So taking the sum for all y in the support, f of sy. So taking the sum for all y in the support, f of sy. When s is 0, find the sum for all y's. I get 1 over 16 here. When s is 1, find the sum for all y's. I get 4 over 16. When s is 2, find the sum for all y's. I find the sum of the entire row. That's 6 over 16. When s is 3, find the sum for all y's. So I find the sum for the entire row. That's 4 over 16. When s is 4, find the sum for all y's. So I find the sum for the entire row. I get 1 over 16. So if I find the sum for all y's, the marginal probability function of x is 1 over 16 if s equal to 0 and 4. It's 4 over 16 if s equal to 1 and 3. It's 6 over 16 if s equal to 2. That's the marginal probability function of x. Next, we find the marginal probability function of y. Since x and y they are discrete random variables, for marginal probability function of y, we find the sum for all x in the support of x, f of sy. Find the sum for all x in the support of x. When y equal to 1, we find the sum for all x in the support of x. That's the sum of the first column, which is 8 over 16. When y is 2, we find the sum for all x in the support, which is the sum of the second column. That's 4 over 16. When y equals 3, we find the sum for all x in the support. That's the sum of the third column, which is 2 over 16. When s is 4, when y is 4, we find the sum for all x in the support. Find the sum for all x in the support, which is the sum of the entire column. That's 1 over 16. When y equal to 5, find the sum for all x in the support, which is the sum of the last column. That's 1 over 16. So the marginal probability function of y a over 16 if y equal to 1. 4 over 16 if y equal to 2. 2 over 16 if y equal to 3. And 1 over 16 if y equal to 4 and 5. That's the marginal probability function of y. Now next, we try to determine whether x and y they are independent random variables. For if x and y they are independent random variables, it must satisfy that f sub x of x times f sub y of y equal to f of sy for all x and y. It must satisfy these properties. The marginal probability function of x times marginal probability function of y times, if I multiply them together, it must equal to f of sy for all sy. So let's verify every box here. Let's verify every box. If in every box it satisfies properties, then we say x and y they are independent random variables. But if in one of the box it doesn't satisfy this equation, then x and y they are not independent random variables. Let's test the box. Let's test the first box here. First box. When sy equal to 0, 1, f of sy equal to f of 0, 1 equal to 0. What's fx of 0? Fx of 0, when s is 0, f sub x is 1 over 16. Next, what's f sub y of 1? What's f sub y of 1? When y is 1, f sub y is a over 16, which is half. Let's verify their product. F sub x of 0 times f sub y of 1 equal to 1 over 16 times 1 over 2. That's 1 over 32, which doesn't equal to f of 0, 0. F of 0, 1. So when sy is 0, 1, it doesn't satisfy that f sub x of x times f sub y of y equal to f of sy. So f sub x of x times f sub y of y doesn't equal to f of sy. For sy equal to 0, 1, then x and y they are not independent random variables. Then x and y they are not independent random variables. Number 3. Lucy planned to lose her weight by jogging every day. The x represents the number of miles she jogs, and the y represents the weight she loses in ounces in a day. Assume the joint probability function is given in the table. Assume this is a joint probability function. In a particular day, find each of the following probabilities. Part A. What's the probability that Lucy loses more than 3 ounces? Here, y represents the weight she loses in a day. So we're looking for probability that y is greater than or equal to more than 3 ounces. We're looking for probability that y is greater than 3. here, since y could be 0, 1, 2, 3, 4, 5. If y is greater than 3, y could be either 4 or 5. Y could be either 4 or 5. And here x is not specified. It doesn't specify x. That means x could be any numbers. X could be 1, 2, or 3. So when y is 4, we have f of 1, 4, f of 2, 4, f of 3, 4. When y is 4, s could be 1, 2, 3. When y is 5, s could also be 1, 2, 3. Plus 1, 5, 2, 5, and 3, 5. When y is 4, s could be 1, 2, 3. When y is 5, s could also be 1, 2, 3. Then find the probability and adding up. F of 1, 4 is 0.02. F of 2, 4 is 0.05. F of 3, 4 is 0.03. F of 1, 5 is 0.01. F of 2, 5 is 0.03. F of 3, 5 is 0.01. Adding up, we get 0.15. That's part A. Part B. What's the probability that Lucy jogs exactly 1 mile? What's the probability that Lucy jogs exactly 1 mile? X represents the number of miles she jogs. So part B, we're looking for probability that S equal to 1. Well, S equal to 1, since it doesn't specify y could be any numbers in the support. Y could be 0, could be 1, could be 2, could be 3, could be 4, could be 5. So when S is 1, y could be 0, 1, 2, 3, 4, 5. So we have 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5. When S is 1, y could be 0, 1, 2, 3, 4, 5. When S is 1, y could be 0, 1, 2, 3, 4, 5. Then let's find the probabilities and adding up. We have 0.04 plus 0.13 plus 0.07 plus 0.03 plus 0.02 plus 0.01. Then adding up, we have that's 0.10. That's 0.20. 0.10 plus 0.20 is 0.30. Adding up, we get 0.30. Part C. If Lucy jogs more than 1 mile, what's the probability that she loses fewer than 2 ounces? That's a conditional probability. If we know that Lucy jogs more than 1 mile, what's the probability that she loses fewer than 2 ounces? If Lucy jogs more than 1 mile, what's the probability that she loses fewer than 2 ounces? This is conditional probability. It's known that Lucy jogs more than 1 mile. It's known that Lucy jogs more than 1 mile. What's the probability that she loses fewer than 2 ounces? If she loses fewer than 2 ounces, y must be less than 2. Y represents the weight she loses in a day. This is conditional probability. The numerator is the intersection x greater than 1, y less than 2. The denominator is the probability that x greater than 1. Let's find the numerator and denominator individually and then divide. Let's find the numerator and denominator individually and then divide. For the numerator, probability that x greater than 1 y less than 2. If s is greater than 1, s could be either 2 or 3. If y is less than 2, y must be either 0 or 1. So if s is greater than 1, s could be 2 or 3. If s is greater than 1, s could be 2 or 3. Y is less than 2, y could be 0 or 1. So we have when s is 2, y could be 0 or 1. When s is 3, y could also be 0 or 1. Then find the probabilities and add them up. F of 2 comma 0 is 0.05. F of 2 comma 1 is 0.10. F of 3 comma 0 is 0.01. F of 3 comma 1 is 0.02. That's 0.18. If I add them up, that's 0.18. That's the numerator. Then for the denominator, probability that x greater than 1. If s is greater than 1, s could be either 2 or 3. And since it doesn't specify y could be 0, 1, 2, 3, 4, or 5. So when s is 2, we have f of 2 comma 0 plus f of 2 comma 1 plus f of 2 comma 2 plus f of 2 comma 3 plus f of 2 comma 4 plus f of 2 comma 5. When s is 3, we have f of 3 comma 0, f of 3 comma 1, f of 3 comma 2, f of 3 comma 3, f of 3 comma 4, f of 3 comma 5. Then find the probabilities and add them up. Find the probabilities and add them up. F of 2 comma 0 is 0.05. F of 2 comma 1 is 0.10. F of 2 comma 2 is 0.15. F of 2 comma 3 is 0.12. F of 2 comma 4 is 0.05. F of 2 comma 5 is 0.03. F of 3 comma 0 is 0.01. F of 3 comma 1 is 0.02. F of 3 comma 2 is 0.03. F of 3 comma 3 is 0.10. F of 3 comma 4 is 0.03. F of 3 comma 4 is 0.01. If we add them up, the probability is 0.70. If we add this number up, it's 0.70. So that's the numerator, that's the denominator, and then divide. So probability that y is less than 2, given that s is greater than 1, it's 0.18 divided by 0.70. That's 9 over 35. If we round to 4 decimal places, that's 0.2571. That's part C. Part D. If Lucy loses 5 ounces, what's the probability that she jogs 2 miles? Part D. If Lucy loses 5 ounces, what's the probability that she jogs 2 miles? If Lucy loses 5 ounces, y represents the weight she loses. So what's given is probability that y equal to 5. What's given is probability that y equal to 5. What we are looking for is the probability that she jogs 2 miles. X represents number of miles she jogs. So what we are looking for is probability that S equal to 2. So we're looking for probability that S equal to 2 given that Y equal to 5. This is a conditional probability. That's probability that S equal to 2, Y equal to 5, over probability that Y equal to 5. Let's find the numerator and denominator individually and then divide the answers. Probability that S equal to 2 and Y equal to 5. That's f of 2 comma 5. That's f of 2 comma 5. F of 2 comma 5 is 0.03. Probability that Y equal to 5. Since it doesn't specify x, s could be any numbers. When Y equal to 5, s could be 1, 2, or 3. Since it doesn't specify x, when Y equal to 5, s could be 1, 2, or 3. So when Y equal to 5, s could be 1, 2, or 3. Could be 1 comma 5, 2 comma 5, or 3 comma 5. Since it doesn't specify x, s could be either 1, 2, or 3. Adding up, f of 1 comma 5 is 0.01. F of 2 comma 5 is 0.03. F of 3 comma 5 is 0.01. So we get 0.01 plus 0.03 plus 0.01. Together that's 0.05. That's the numerator, that's the denominator. That's the numerator, that's the denominator, and then divide the answers. Probability that S equal to 2 given that Y equal to 5 is the probability that 0.03 divided by 0.05, which is 3/5. 3/5 is 0.6. Number 4. A number is randomly selected on the interval from 0 to 10, and another number is randomly selected on the interval from 0 to 20. Part A. What's the probability that the first number is greater than the second number? Part B. What's the probability that the sum of these two numbers is less than 20? Part C. What's the probability that the product of these two numbers is greater than 100? Part D. If the first number is more than 5, what's the probability that the second number is greater than the first number? So let's first of all set down the problem first. Let's set down the problem first. Let the random variable x represent the value of the number select from the interval 0, 10, and let the random variable y represent the value of the number select from the interval from 0 to 20. Here, since for x, we are randomly choose a number from the interval 0 to 10. Every number in the interval have the same chance to be chosen. X has a continuous uniform distribution. And similarly, y also has continuous uniform distribution. So, x has continuous uniform distribution over the interval from 0 to 10. Y also has continuous uniform distribution. Y also has continuous uniform distribution over the interval from 0 to 20. Then the probability function of x, let me use f1 to represent the PDF of x. The probability function of x, since it's uniform distribution, is 1 over beta minus alpha. Here alpha is 10, alpha is 0, beta is 10. 10 minus 0 is 10. So f1 of x is 1 over 10 if s is between 0 and 10. Zero otherwise. And let me use f sub 2 to represent the probability density function of y. Let me use f2 to represent the PDF of y. f2 of y. Y also has uniform distribution. It should be capital Y here. It should be capital Y here. Y also has uniform distribution. Formula for continuous uniform distribution is 1 over beta minus alpha. 20 minus 0 is 20. If y is between 0 and 20, and 0 otherwise. And in general, we know that the marginal probability density function of x is identical to the probability density function of x. And the marginal probability density function of y is identical to the probability density function of y. Since we choose two numbers from these two intervals individually, they are independent random variables. X and y, they are independent random variables. Since x and y are independent random variables, then we know that the joint probability density function, the joint PDF of x and y, is the marginal PDF of x times the marginal PDF of y. Since x and y, they are independent random variables. So the joint PDF can be written as f sub x times f sub y. 1 over 10 times 1 over 20 is 1 over 200. If s is between 0 and 10, y is between 0 and 20, and 0 otherwise. That's the joint PDF of x and y. Next, let's find the support. Let's find the support of x and y. For support of s and y, is the set of all sy in R2 such that f of sy is greater than 0. Here is in the region that x is between 0 and 10, and y is between 0 and 20. For the support, we must consider the closure, which means we must include all the boundaries. For the support, we must consider use the closure, which means we must include all boundaries. We must include the boundary 0 and 10, the boundary 0 and 20. That's the support of s and y. If I draw the support, it looks like this. X from 0 to 10, y from 0 to 20. That's the support of x and y. Now let's answer the question. Part A. What's the probability that the first number is greater than the second number? The first chosen number is greater than the second chosen number. So in part A, we are looking for probability that x is greater than y. In part A, we're looking for the probability that x is greater than a, x is greater than y. The probability that the first chosen number is greater than the second chosen number. Now, how do we draw x greater than y? In general, we try to write y. Try to write y on the left side. X is greater than y means y is less than x. Let's first of all graph the line y equal to x. Let's first of all graph the line y equal to x. Y equal to x is a straight line. The slope is 1, y-intercept is 0. That's the line y equal to x. But here we have y less than x. Since y is less than a function of x, we shade the region below the curve. Since y is less than x, y is less than a function of x, we shade the region below the curve. And here, since we don't have equal sign below inequality, we don't include the boundary. So we draw a dashed line for y equal to x. We draw a dashed line for y equal to x. For this probability, we try to take integral over this region here. For this region, upper bound, upper curve is y equal to x. Lower curve is y equal to 0. We must take double integral. Lower curve is y equal to 0. Upper curve is y equal to x. For this region, x varies from 0 to 1, 0 to 10. On this region, x varies from 0 to 10. The PDF is 1 over 200 dy dx. The order matters. It must be dy dx. Then we solve for the inner integral first. Keep an outer integral the same. Take the inner integral first. We get 1 over 200 times y. Y varies from 0 to x. If I plug in x, I have 1 over 200x. If I plug in 0, I get 0. So I have 1 over 200x times dx. Then take another antiderivative with respect to x. I get 1 over 200 times s squared over 2. X varies from 0 to 10. If I plug in 10, 10 squared is 100. If I divide top and bottom by 100, I get 2 here. So the answer is 1 over 4. If I plug in 0, I get 0. So the answer is 1 over 4. Probability is 1 over 4. So the probability that the first number is greater than the second number is 1 over 4. That's part A. Part B. What's the probability that the sum of these two numbers is less than 200? Part B. What's the probability that the sum of these two numbers is less than 20? We're looking for probability that the sum of these two numbers is less than 20. Probability that s plus y is less than 20. In general, we try to write y on the left side. So this can be rewrite as probability that y is less than 20 minus x. Probability that y is less than 20 minus x. Next, let's draw the support. For support, x is from 0 to 10, y is from 0 to 20. Support is this rectangular region. X from 0 to 10, y from 0 to 20. Next, let's graph the line. Let's graph y equal to 20 minus x first. Let's graph y equal to 20 minus x first. This line, y-intercept is 20. This is a straight line. Y-intercept is 20. Slope is negative 1. Y-intercept is 20. Slope is negative 1. Since y is less than a function of x, Since y is less than the function of x, we straighten the region below the curve. And since there's no equal sign below inequality, we draw a dashed line for this line. We draw a dashed line. That means we don't include a boundary. That's the line y equal to 20 minus x. Since y is less than the function of x, we straighten the region below the curve. So try to take integral over this region here, over the shaded region here. Lower bound is y equal to 10. Upper bound is y equal to 20 minus x. X varies from 0 to 10. And the PDF is 1 over 200 dy dx. Solve the inner integral first. For the inner integral, take antiderivative with respect to y. Take antiderivative with respect to y. I get 1 over 200 y. Y varies from 0 to 20 minus x dx. Then plug in upper and lower limit and take difference. Plug in upper and lower limits, take difference. If I plug in upper limit, I get 1 over 200 times 20 minus x. If I plug in 0, I get 0. Next, take antiderivative with respect to x. I get 1 over 200 times 20x minus x squared over 2. X varies from 0 to 10. If I plug in 10, 10 squared is 100. 100 over 2 is 50. 20 times 10 is 200. 200 take away 50 is 150. So we get 150 over 200. If I plug in 0, I get 0. So here, 150 over 200, if I reduce it, that's 3 over 4. So the probability that the sum of these two numbers is less than 20 is 3 over 4. That's the answer to part B. That's the answer to part B. Part C. What's the probability that the product of these two numbers is greater than 100? What's the probability that the product of these two numbers is greater than 100? Part C. What's the probability that the product of these two numbers, x times y, is greater than 100? What's the probability that the product of these two numbers is greater than 100? So in general, we try to keep y on the left side. Isolate y on the left side. First of all, try to isolate y on the left side. So this probability can be rewritten as probability that y is greater than 100 over x. Probability that y is greater than 100 over x. Next, in order to set out the integral, let's draw the support first. In order to set out the integral, let's draw the support first. Let's draw the support first. Support is a rectangular region, the x from 0 to 10, y from 0 to 20. Next, let's graph the line. Let y equal to 100 over x. Let's graph the line y equal to 100 over x. This is a hyperbola. This is a hyperbola. Looks like this. This is a hyperbola. Looks like this. Now, when s equal to 10, if I plug in 10 for x, y equal to 100 over 10, y must be 10. When s is 10, y must be 10 here. When y is 20, if y is 20, if I plug in 20 for y, x must be 5. 100 over 4 is 20. So that's the intersection on this line and this line. That's a graph. That's a graph of y equal to 100 over x. It's part of this curve. Now, since y is greater than the function of x, we show the region above the curve. Since y is greater than the function of x, we show the region above the curve. And also, since there's no equal sign below inequality, we must draw a dashed line. That means the boundary is not included. Solid line means boundary is included. Dashed line means the boundary is not included. But when we take integral, it doesn't really matter. When we draw the graph, we don't include the boundary. We use dashed line. Dashed line means the boundary is not included. Here, lower bound is y equal to 100 over x. Upper bound is y equal to 20. That's the lower bound. That's the upper bound. So y is from 100 over x to 20. What's x? Be very careful. In this region, in the shaded region here, x varies from 5 to 10. In the shaded region here, x varies from 5 to 10. The joint PDF is 1 over 200. The joint PDF is 1 over 200. Then dy dx. Next, we take antiderivative with respect to y. Solve the inner integral first. Take antiderivative with respect to y. Keep the outer integral the same. Take antiderivative with respect to y. I get 1 over 200 times y. Y varies from 100 over x to 20 dx. Then plug in the upper and lower limit and take difference. If I plug in upper limit, I get 20. If I plug in the lower limit, I get 100 over x dx. Here, make it a little easier. Distribute 1 over 200. Distribute 1 over 200. If I distribute 1 over 200, 1 over 200 times 20 is 1 over 10. 1 over 200 times 100 over 2, 100 over x is 1 over 2 times 1 over x dx. Next, take antiderivative with respect to x. I get 1 over 10x minus half of ln of x. X varies from 5 to 10. If I plug in 10, I get 1 minus half of ln of 10. If I plug in 5, I get half minus half times ln of 5. Then here, 1 minus half is half. For these two terms, I can pull out negative half. If I pull out negative half, I have ln of 10 minus ln of 5. That's half minus half of ln of, I can convert subtraction to division. 10 divided by 5. I get ln of 10 divided by 5. 10 divided by 5 is 2. So that's the answer. Half minus half of ln of 2. Here we can use calculator. If I use calculator, the answer is 0.1534. Answer is 0.1534. That's the probability that the product of these two numbers is greater than 100. Part D. If the first number is more than 5, if it's known that first number is more than 5, what's the probability that the second number is greater than the first number? This is conditional probability. Part D, this is conditional probability. If it's known that the first number is greater than 5, what's the probability that the second number is greater than the first number? This is conditional probability. So if we use the formula, that's probability that x is greater than 5 and y is greater than x over the probability that x is greater than 5. This is conditional probability. We must find each probability individually and then divide the answers. We must find each probabilities individually and then divide the answers. Let's find the numerator first. Numerator, probability that x is greater than 5, y is greater than x. In order to find this integral, in order to find this probability, let's draw the support first. Then based on the support, we set down the integral. Support is a rectangular region. X is from 0 to 10. Y is from 0 to 20. We try to find a region that satisfies both equations, both inequalities. X is greater than 5. 5 is here. For x greater than 5, 5 is here. The region to the right side of 5 is 5 greater than 5. X greater than 5. The region to the right side here, then represent x greater than 5. Next, for y greater than x, I first of all write down y equal to x. Let's first of all graph the line y equal to x. That's the line y equal to x. Since y is greater than the function of x, we show the region above the curve. X greater than 5, y greater than x. So to take integral over this region. This region satisfies both conditions. So take integral over this region. For this region, the lower bound is y equal to x. Upper bound is y equal to 20. In this region, x varies from 5 to 10. So lower bound is y equal to x. Upper bound is y equal to 20. In this region, x varies from 5 to 10. And the joint PDF is 1 over 200 dy dx. That's the joint PDF. Here, take the inner integral first. Take antiderivative with respect to y. I get 1 over 200 y. Y varies from x to 20 dx. Then I plug in upper and lower limit and take difference. X is from 5 to 10. If I plug in upper limit, I get 20. If I plug in lower limit, I get x. Dx. Next, take antiderivative with respect to x. I get 20x minus x squared over 2. X varies from 5 to 10. If I plug in 10, 20 times 10 is 200. 10 squared is 100. 100 over 2 is 50. 200 minus 50 is 150. If I plug in 5, 20 times 5 is 100. 5 squared is 25. 25 over 2 is 12.5. 100 minus 12.5 is 87.5. Then use calculator. Here I get 5 over 16. Next, let's find a probability for the denominator. Probability that x is greater than 5. Let's again draw the support. Support is in the rectangular region. The x is from 0 to 10, y is from 0 to 20. We're looking for the region that x is greater than 5. 5 is here. The region to the right side. Region to the right of 5. That's the region that x is greater than 5. So take a region over this integral, over this region. Take integral over this region. Lower bound here is y equal to 0. Upper bound is y equal to 20. For this region, lower bound is y equal to 0. Upper bound is y equal to 20. And in this region, x varies from 5 to 10. The joint PDF is 1 over 200 dy dx. Then take the inner integral first. Take antiderivative with respect to y. We get 1 over 200y. Y varies from 0 to 20. Leave an outer integral the same. Then plug in the upper and lower limit and take difference. If I plug in upper limit, I get 20. If I plug in lower limit, I get 0. 20 minus 0 is 20. That's 1 over 10 dx. Next, take antiderivative with respect to x. I get 1 over 10 times x. X varies from 5 to 10. If I plug in 10, I get 10. If I plug in 5, I get 5. 10 minus 5 is 5. 1 over 10 times 5 is half. That's the probability of the denominator. That's the denominator. Probability that s is greater than 5. So finally, for the probability that y is greater than x, given that s is greater than 5, we use the numerator divided by the denominator. The numerator is 5 over 16. Denominator is half. That's 5 over 16 times 2 over 1, which is 5 over 8. That's the probability that the second number is greater than the first number, given that the first number is greater than 5. Number 5. Let x and y be continuous non-variable with the joint probability density function. With the joint probability density function f of sy equal to s squared plus cy if s is between 0 and 1 and y is between 0 and 2. 0 otherwise. Part A, find the value of the constant c. Part B, find the probability that 2s plus y is less than 20. Part C, find the marginal probability density function of x and y and determine whether x and y are independent random variables. Let's do part A first. Find the value of the constant c. The joint probability density function, the joint PDF, here is x squared plus cy if s is between 0 and 1 and y is between 0 and 2. 0 otherwise. Let's draw the support first. In order to take integral, let's draw the support first. support of Sy is a region that f of Sy is greater than 0. So here is the region of x and y in R2. And for the support, we must include the boundary. S is between 0 and 1, including the boundary. Y is between 0 and 2, including the boundary. That's the support of S and Y. For the support of S and Y, we must include the boundaries. It's the closure of the set. We must include the boundary. We know that the total probability must be 1. If I take integral over the support, I must get 1. If I take a double integral over the support, I must get 1, because the total probability must be 1. So take integral. Lower bound is y equal to 0. Upper bound is y equal to 2. That's a lower curve, that's an upper curve. In this region, x varies from 0 to 1. The joint PDF here is s squared plus cy. No square here. S squared plus cy. dy dx. First of all, let's take the inner integral first. Keep an outer integral the same. Take the inner integral first. For inner integral, take an antiderivative with respect to y. Here we treat s as constant. So I get s squared y plus cy squared over 2. Y varies from 0 and 2 dx. Take the inner integral first. Then I plug in upper and lower limit for y, and then take difference. If I plug in 2 for y, I get 2s squared. If I plug in 2 for y, 2 squared is 4. 4 over 2 is 2. I get 2c here. If I plug in 0 for y, I get 0. Next, take antiderivative with respect to x. Here I get 2s cubed over 3 plus 2cx. X is from 0 to 1. Next, plug in the upper and lower limit and take difference. If I plug in upper limit, if I plug in 1, I get 2 over 3 plus 2c. If I plug in 0, I get 0. That's the probability over the support. We know that the total probability must be 1. So I set 2 over 3 plus 2c equal to 1. Then I can solve the equation for c. Here I get 2c equal to 1/3. Then divide both sides by 2. C is 1 over 6. That's part A. Find the value of C. Part B. Find the probability that 2x plus y is less than 2. Find the probability that 2x plus y is less than 2. In general, we try to isolate y on the left side. This probability can be rewritten as probability that y is less than 2 minus 2x. In order to find this probability, we must take integral. So let's first draw the support. For the support, s is from 0 to 1. Y is from 0 to 2. Support is a rectangular region. X is from 0 to 1, y is from 0 to 2. Next, let's graph the line. y equal to 2 minus 2x. Let's graph the line. Y equal to 2 minus 2x. This is a straight line. Y-intercept is 2. Slope is negative 2. Y-intercept is 2. Slope is negative 2. By the way, what's the s-intercept? What's the s-intercept? If I plug in 0 for y, solve for x, s must be 1. So s-intercept is 1. Since y is less than a function of x, we treat the region below the curve. And there's no equal sign below inequality, it must be a dashed line. The curve must be a dashed line here. And we treat the region below the curve, since y is less than a function of x. For this region here, lower curve is y equal to 0. Upper bound, the upper curve is 2 minus 2x. Next, we take integral over this region. For this region, y varies from 0 to 2 minus 2x. X varies from 0 to 1. And the joint PDF is s squared plus cy. Join the PDF is s squared plus cy. Here, c is 1 over 6. So the join the PDF is s squared plus cy, where c is 1 over 6. dy dx. Next, take antiderivative with respect to y. Do the inner integral first. Take antiderivative with respect to y. We leave the outer integral the same. Take antiderivative with respect to y. I get s squared y plus 1 over 6 times y squared over 2. Y is from 0 to 2 minus 2x dx. Next, we plug in the upper and lower limit and take difference. Plug in the upper and lower limits and take difference. If I plug in the upper limit, I get s squared times 2 minus 2x plus 1 over 12 times 2 minus 2x squared. If I plug in the lower limit, I get 0. Next, simplify the integral. If I distribute x squared, I get 2s squared minus 2s cubed. For the second part, I first of all expand the perfect square. I get 4 minus ax plus 4s squared. Then distribute 1 over 12. That's 1 over 3 minus 2/3 of x plus 1/3 of s squared. If I combine like terms, I have negative 2s cubed. 2s squared plus 1/3 s squared, I get 7 over 3 s squared. Minus 2/3 of x plus 1/3 dx. Next, take antiderivative with respect to x. We get negative x to the power 4 over 2 plus 7 over 9 times s cubed minus 1/3 of x squared plus 1/3 of x. Evaluate from 0 to 1. Then we plug in the upper and lower limit and take difference. If I plug in upper limit, I get negative 1 over 2 plus 7 over 9 minus 1/3 plus 1/3. If I plug in 0, I get 0. Then negative 1/3 positive 1/3 can cancel. negative 1 over 2 plus 7 over 9, I get negative 9 plus 14, that's 5 over 18. That's the probability that 2x plus y is less than 2. Part C. Find the marginal probability density function of x and y and determine whether x and y are independent random variables. Let's find the marginal probability density function of x first. Since x and y, they are continuous random variable, so here I'll take integral for y from net infinity to infinity, f of sy dy. In order to take the integral, let's draw the support first. Here the support is a rectangular region where x is from 0 to 1, y is from 0 to 2. That's the support of x and y. That's the support of x and y. We'll take integral for y. Lower bound is y equal to 0. Upper bound is y equal to 2. That's the lower bound, that's the upper bound. So take integral from y equal to 0 to y equal to 2. And the joint PDF is s squared plus cy. C is 1 over 6 dy. Here we take antiderivative with respect to y. That means I treat s as constant. So I have s squared y plus 1 over 6 times y squared over 2. Evaluate y from 0 to 2. If I plug in 2 for y, I get 2s squared. If I plug in 2 for y, 2 squared is 4. 4 over 12 is in a sense 1/3. So that's the marginal probability density function of x. That's the marginal probability density function of x. Next, we try to find the marginal probability density function of y. Since x and y, they are continuous random variable. So for marginal probability density function of y, I take integral for x from net infinity to infinity, f of sy dx. And look at support here. For dx, we try to integrate from left side curve to right side curve. For dx, we try to take integral from left side curve to right side curve. Here, left side curve is this straight line here. This is the line s equal to 0. This line is s equal to 1. So take integral from left side curve to right side curve. Here s is from 0 to 1. F of sy is s squared plus cy, where c is 1 over 6. Here we take antiderivative with respect to x. If we take antiderivative with respect to x, I treat y as constant. I have s cubed over 3 plus 1 over 6 y times x. Evaluate x from 0 to 1. So I plug in the upper limit and lower limit for x and take difference. If I plug in the upper limit for x, I get 1 over 3 plus 1 over 6y. If I plug in 0 for x, I get 0. That's 1 over 3 plus 1 over 6y. So the marginal probability density function of y is 1 over 6y plus 1 over 3. That's the marginal probability density function of y. Next, we try to determine whether x and y, they are independent random variables. So try to verify their product. if the marginal PDF of x times the marginal PDF of y equal to the joint PDF f of sy, then s and y, they are independent random variables. Otherwise, they are not independent random variables. So let's multiply. So f sub x of x is 2x squared plus 1/3 times 1/6y plus 1/3. If we multiply the marginal PDF of x and y, it's very clear. You can see that we won't get x squared plus cy. We won't get x squared plus cy. So that's not the same as f of sy. So x and y, they are not independent random variables. They are not independent random variables. Number 6. Let x and y be continuous random variables with joint probability density function f of sy. F of sy equal to 16s cubed times y if s is between 0 and 1 and y is between 0 and s squared. 0 otherwise. Part A. Find the expected value of x and the variance of x. Part B. Find the expected value of y and the variance of y. Part C. Find the expected value of xy and the variance of sy. Let's do part A first. Find the expected value of x and variance of x. Here, since x and y, they are continuous random variable, in order to find the expected value, we must take integrals. In order to take integrals, we must draw the support first. Let's draw the support first. What's the support of s and y? Support of s and y is the set of all sy in R2 such that s is between 0 and 1 and y is between 0 and s squared. How do we draw the support here? S is between 0 and 1. S is between 0 and 1. Y is between 0 and s squared. So the lower bound is y equal to 0. Upper bound is y equal to s squared. The lower bound is y equal to 0, which is the s-axis. Lower bound is y equal to 0. That's an s-axis. Upper bound is y equal to s squared. That's a parabola. Open upward. That's a parabola open upward. Vertex located at the origin. So it looks like this. That's an upper bound, y equal to s squared. What's the intersection here? What's the intersection here? When s is 1, we plug in 1 for x. 1 squared is 1. So when s is 1, y is also 1. That's the support. S is between 0 and 1. Y is between 0 and s squared. This is the support of s and y. This is the support of s and y. Now part A. Find the expected value of x. For expected value of x, since x and y are continuous random variables, we take integral from net infinity to infinity, x times f of sy. dx, dy, or dy dx, doesn't matter. Next, we try to take integral over the support. In the support, the lower bound is y equal to 0. Upper bound is y equal to s squared. And in this region, x values from 0 to 1. X times f of sy. The joint PDF here is 16x cubed times y. dy dx. X is from 0 to 1. If I multiply, I get 16x to the power 4 times y dy dx. Now take the inner integral first. S is from 0 to 1. Take the inner integral first. I take antiderivative with respect to y. I get 16x to the power 4 times y squared over 2. Evaluate from 0 to s squared dx. Then x is from 0 to 1. If I plotting s squared for y, I get x to the power of 4. X to the power 4 times x to the power 4 is x to the power of a. 16 divided by 2 is a. If I plug in 0 for y, I get 0. Then take antiderivative with respect to x. I get ax to the power 9 over 9. Evaluate from 0 to 1. If I plug in 1, I get a over 9. If I plug in 0, I get 0. So expressive value of x is a over 9. Next, we try to find variance of x. Variance of x is expressive value of x squared minus expressive value of x squared. In order to find variance of x, we must find expressive value of x squared first. So for expressive value of x squared, we take double integral x from net infinity to infinity, y from net infinity to infinity. Take s squared times the joint PDF f of sy, ds dy or dy over or ds dy or dy ds, doesn't matter. Now next, we must take integral over the support. Over the support here, lower bound is y equal to 0, upper bound is y squared, y equal to s squared. X values from 0 to 1. Take s squared times 16x cubed times y. ds dy. Sorry, dy ds. It must be in this order. dy times dx. Take s squared times the joint PDF. The joint PDF is 16x cubed times y. That's the joint PDF. Then simplify the integrand first. I get 16x to the power 5 times y dy dx. Then take the inner integral first. Keep the outer integral the same. I get 16x to the power 5 times y squared over 2. Evaluate y from 0 to s squared. Evaluate y from 0 to s squared dx. If I plug in s squared for y, I get x raised to power 4. X raised to the power 4 times x to the power 5 is x raised to power 9. Then 16 divided by 2 is a. Next, take antiderivative with respect to x. I get ax to the power 10 over 10. Evaluate from 0 to 1. If I plug in 1 for x, I get 4 over 5. If I plug in 0 for x, I get 0. Next, I can find variance of x. Variance of x is expressive value of x squared minus its derivative of x squared. That's 4 over 5 minus its derivative of x is a over 9. So we get 4 over 5 minus a over 9 squared. Then here I use my calculator. I get 4 over 405. Less than the variance of x. Part B. Find the derivative of y and the variance of y. For its derivative of y, we take double integral x from net infinity to infinity, y from net infinity to infinity. Take y times f of sy, y times the joint PDF, times dx dy or dy times dx, it doesn't matter. Next, take integral over the support. Over the support here, lower bound is y equal to 0, upper bound is y equal to s squared. And x varies from 0 to 1. Y times f of sy. F of sy is 16x cubed times y. dy dx. Then multiply this first. If I multiply, I get 16x cubed times y squared dy dx. Then solve the inner integral first. If I solve the inner integral, I take antiderivative with respect to y. I get 16 times s cubed times y cubed over 3. Evaluate y from 0 to s squared. Leave an outer integral the same. Then plug in upper and lower limit, take difference. If I plug in upper limit, if I plug in s squared for y, I get x raised to power 6. X raised to power 6 times s cubed will be x raised to power 9. 16 over 3 stays the same. If I plug in 0 for y, I get 0. Next, take antiderivative with respect to x. I get 16 over 3 times x to the power 10 over 10. Evaluate from 0 to 1. If I plug in 1, I get 16 over 3 times 1 over 10. I can divide top and bottom by 2. I get a over 15. If I plug in 0, I get 0. So its derivative of y is 8 over 15. Next, we try to find variance of y. Variance of y is its derivative of y squared minus its derivative of y squared. In order to find variance of y, we must find its derivative of y squared first. So let's find its derivative of y squared. Let's the double integral from net infinity to infinity. Y squared times the joint PDF f of sy. Dx times dy or dy times dx. The order doesn't matter here. Next, take integral over the support. Take integral over the support. On the support here, lower bound is y equal to 0. Upper bound is y equal to s squared. So y equal to 0, y is from 0 to s squared. S is from 0 to 1. Take y squared times the joint PDF. The joint PDF in the support is 16s cubed times y dy dx. Then multiply y squared with y. Multiply y squared with y. I get 16x to the power 3 times y to the power of 3 dy dx. Then take the inner integral first. Leave an outer integral the same. I get 16s cubed times y raised to power 4 over 4. Evaluate from y equal to 0 to y equal to s squared dx. Then plug in the upper limit and lower limit, and then take the difference. X is from 0 to 1. If I plug in s squared for x, for y, if I plug in s squared for y, I get x raised to power a here. X raised to power a times x to the power 3, I get x raised to power of 11. And then for the numbers here, 16 divided by 4 is 4. If I plug in 0 for y, I get 0. So I get 4x raised to 11 times dx. Then take antiderivative with respect to x. I get 4x raised to 12 over 12. Evaluate from 0 to 1. If I plug in 1 for x, I get 4 over 12, which is 1/3. If I plug in 0 for x, I get 0. So expected value of y squared is 1/3. Next, for variance of y, we take expected value of y squared minus expected value of y squared. So for variance of y, I take expected value of y squared minus expected value of y squared. Expected value of y squared is 1/3. Expected value of y is a over 15 squared. Then use calculator. Take 1/3 minus a over 15 squared. Here I use my calculator. I get 11 over 225. Part C. Find the expected value of sy and the variance of sy. So very similar. For expected value of x times y, we take double integral from net infinity to infinity. Take sy times the joint PDF f of sy times dx dy or dy dx, it doesn't matter. Next, take double integral over the support. Over the support here, the lower bound is y equal to 0, upper bound is y equal to s squared. Lower bound is y equal to 0, upper bound is y equal to s squared. X is from 0 to 1. In the support here, x varies from 0 to 1. Then take sy times the joint PDF. The joint PDF in the support is 16s cubed times y. dy dx. Next, we simplify the integrand first. S is from 0 to 1, y is from 0 to s squared. If I multiply, I have 16x raised to power 4, y raised to power 2, dy dx. Next, we solve the inner integral first. Take antiderivative with respect to y. I leave the outer integral the same. Take antiderivative with respect to y. I get 16x raised to power 4, y to the power 3 over 3. Evaluate y from 0 to s squared dx. Then we plug in the upper and lower limit and take difference. If I plug in upper limit for y, I get x raised to power 6 here. X raised to power 6 times x raised to power 4, that's x raised to power 10 times 16 over 3. If I plug in 0 for y, I get 0. So I get 16 over 3 times x to the power 10 dx. Next, take antiderivative with respect to x. Here I get 16 over 3 times x raised to power of 11 over 11. Evaluate from 0 to 1. If I plug in 1 for x, I get 16 over 33. If I plug in 0 for x, I get 0. So expected value of sy is 16 over 33. Next, we try to find variance of sy. Variance of sy is special value of sy square in a bracket, square in a bracket, minus its special value of xy square outside the bracket. That's variance of sy. We know its special value of xy already. In order to find variance of sy, we must find its special value of xy square. Next, let's find its special value of sy square. For its special value of sy square, here we take double integral from negative infinity to infinity. From negative infinity to infinity. Use sy square times the joint PDF f of sy. Dx dy or dy times dx, it doesn't matter. Next, take integral over the support. Take integral over the support. Here in the support, the lower bound is y equal to 0, upper bound is y equal to s squared. In the support, x varies from 0 to 1. Here we have x times y squared is s squared y squared times the joint PDF f of sy. The joint PDF in the support is 16s cubed times y. dy dx. Here in order matters, we must match the integral here, dy dx. Then let's simplify the integrand first. If I multiply, I have 16x raised to power 5, y raised to power 3, dy dx. Next, take the integral first, which means take antiderivative with respect to y first. Leave the outer integral the same. I get 16x to the power 5 times y raised to power 4 over 4. Evaluate from 0 to s squared dx. If I plug in x squared for y, I get x raised to power a here. X raised to power a times x raised to power 5. That's x raised to power of 13. (16 divided by 4 is 4. Next, I plug in lower limit. If I plug in 0 for y, I get 0. So I have integral from 0 to 1, 4x raised to power 3 dx. Next, take antiderivative with respect to x. I get 4x raised to power of 14 over 14. Evaluate from 0 to 1. If I plug in 1 for x, I get 4 over 14, which can be reduced as 2 over 7. If I plug in 0 for x, I get 0. So its special value of sy squared is 2 over 7. Next, for the variance of sy, we use its special value of xy squared minus its special value of sy squared, which is 2 over 7 minus 16 over 33 squared. And here I use my calculator. I get 386 over 7623. If I round to 4 decimal places, that's 0.0506. It's not necessary. We can leave as simple as fraction. That's the variance of sy. 386 over 7623. Number 7. Consider 2 boxes of marbles. Assume the weight of the marbles in each boxes is normally distributed. One box contains only green marbles with a mean of 10 gram and a standard deviation of 1.2 gram. And the other box contains only red marbles with a mean of 8 gram and a standard deviation of 0.9 gram. Part A. When a green marble and a red marble are normally chosen, what's the probability that the green marble weighs less than the red marble? So let's set down the problem first. Let G, then the random variable G, represent the weight of a green marble, Let the random variable R represent the weight of a red marble. Since the weight of the red marble and green marble are normally distributed, so G is the normal distribution with a mean of 10 and a variance of 1.2 squared. R is also a normal distribution with a mean of 8 gram and a variance of 0.9 squared. That's what's given. Part A. What we are looking for is when a green marble and a red marble are randomly chosen, what's the probability that the green marble weighs less than the red marble? So part A, we're looking for the probability that the green marble weighs less than the red marble. In order to find the probability, usually we bring all variables to one side, to the left side. Usually bring all variables to the left side. So I have G minus R is less than 0. Next, I let the random variable X equal to G minus R. Since X is a linear combination of normal random variables, X also has normal random variable. Here I have probability that X less than 0. In order to find a probability for X less than 0, I try to convert X to the standard normal distribution. Then I can use the standard normal CDF to find the probability. Let's first of all find mu and sigma of X. Mu of X is expected value of X. That's expected value of G plus expected value of negative R. That's expected value of G minus expected value of R, which is 10 minus A. Expected value of G is 10. Expected value of R is A. 10 minus A is 2. So mu of X is 2. Next, let's try to find sigma of X. In order to find sigma of X, let's find variance of X first. Variance of X is variance of G plus variance of negative R. When we separate the terms, I must write variance of G plus variance of negative R. Don't write it as variance of G minus variance of R. That's completely wrong. That's wrong. We must write it as variance of G plus variance of negative R. Then for variance, if I pull out the coefficient, I must square the coefficient. For variance, if I pull out the coefficient, I must square the coefficient. So I get variance of G plus -1 square times variance of R. Variance of G is 1.2 square. -1 square is 1 times variance of R. Variance of R is 0.9 square. And here I use my calculator, I get 2.25. Then for sigma of x, I take square root from the variance of x. Take square root for variance of x. I have square root of 2.25, which is 1.5. Once I know mu of x, I know sigma of x, I can convert x to z, the standard normal distribution. The formula is x minus mu of x over sigma of x. Let's probability that z is less than -1.33. Round to 2 decimal places. Use calculator. Round to 2 decimal places. I get -1.33. Then z, probability that z less than -1.33 is phi of -1.33. Then I can use the standard normal CDF to find the probabilities. -1.33 is 0.09176. 0.09176. In general, we round the answer to 4 decimal places. If I round the answer to 4 decimal places, it's about 0.0918. That's part A, the probability that a green marble is less than a red marble. Part B, when 7 green marbles and 9 red marbles are randomly chosen, what's the probability that the total weight of the green marbles is more than the total weight of red marbles? Part B, probability that 7 green marbles with more than 9 red marbles. 7 green marbles, G1 plus G2 plus G7 with more than 9 red marbles. R1 plus R2 plus R9. The total weight of 7 green marbles is more than the total weight of 9 red marbles. Be very, very careful here. Don't use 7G is greater than 9R. If we use 7G greater than 9R, that means the weight of, that's 7G means you pick 1 green marble, multiply its weight by 7. 9R means you pick 1 red marble, multiply its weight by 9. We are choosing different marbles. We don't use the same marble 7 times. We don't use the same green marble 7 times. And we don't use the same red marble 9 times. Since we are choosing different marbles, we must use G1, G2, G7, different green marbles and different red marbles here. We don't use the same marble 7 times. We use different marbles. We pick 7 different marbles. And here we pick 9 different red marbles. Don't use 7G and 9R here. That's wrong. 7G means you take same marble, you use the same marble, multiply its weight by 7. 9R means you pick a red marble and multiply its weight by 9. That's not the case. Here we are choosing 7 different green marbles and 9 different red marbles. Next, we move all variables to the left side. Move all variables to the left side. I have G1 plus G2 plus G7 minus R1 minus R2 minus R9 must be greater than 0. We're looking for probability that this expression is greater than 0. In general, we let this expression be x. Let x equal to G1 plus G2 plus G7 minus R1 minus R2 minus R9. Since x is a linear combination of normal random variables, x also has a normal distribution. Next, this expression can be rewritten as probability that x is greater than 0. Since I let x be this expression, this probability can be rewritten as probability that x is greater than 0. Since x has a normal distribution, we need to convert. We try to use the standard normal CDF to find probabilities. That means we must convert x to the standard normal distribution. So next, we try to find mu of x and sigma of x. For mu of x, we try to find expected value of x, which is the expected value of G1 plus expected value of G2 plus expected value of G7 plus expected value of negative R1 plus expected value of negative R2 plus expected value of negative R9. Next, for expected value, I can pull out negative sign. I get expected value of G1 plus expected value of G2 plus expected value of G7. Pull out negative sign, I get expected value of R1. Pull out negative 1, I get expected value of R2 minus, if I pull out negative sign, I get expected value of R9. Expected value of G is 10. So I get 10 plus 10 plus 10, 7 times. I get 10 plus 10 plus 10 plus 10, 7 times. Expected value of R is A. So I get A minus A minus A, 9 terms. Then use calculator. 10 times 7 is 70. 8 times 9 is 72. 70 minus 72 is negative 2. So mu of x is negative 2. Next, we try to find variance of x. For variance of x, same thing. Separate the terms. We have variance of G1 plus variance of G7 plus variance of negative R1 plus variance of negative R9. Then pull out coefficient. For variance, if I pull out coefficient, I must square the coefficient. So I get variance of G1 plus variance of G7. If I pull out negative 1 here, I get negative 1 square variance of R1 plus negative 1 square variance of R9. Variance of R1, variance of G1 is 1.2 square. We have 1.2 square plus itself 7 terms. Next, negative 1 square is 1. variance of r squared is 0.9 squared. Plus 1 times 0.9 squared. We have 1 times 0.9 squared, 9 terms. Then here I use my calculator. 1.2 squared times 7 plus 0.9 squared times 9. Here I use my calculator. I get 17.37. I get 17.37. So we know that mu of x is -2. Sigma of x, I take square root from the variance. For sigma of x, take square root from the variance. I get square root of 17.37. Sigma of x is square root of the variance, square root of 17.37. And we are looking for probability that x is greater than 0. Here we are looking for probability that x is greater than 0. We must first of all convert x to z first. Then we can use the standard normal CDF to find the probability. If I convert x to z, the formula is x minus mu over sigma. X minus mu over sigma. Then use calculator, round to 2 decimal place. Use calculator, round to 2 decimal place. I get 0.48. So that's the probability that z is greater than 0.48. In order to use the standard normal CDF, I must rewrite the probability in the form of probability that z less than some constant, or probability that z is less or equal to some constant. They both equal to phi of z. They both equal to phi of z. So here we can use the complement. This is the same as 1 minus probability that z is less or equal to 0.48. That's 1 minus phi of 0.48. And for phi of 0.48, I can find it from the table. Phi of 0.48. 0.48 is here. That's 0.68439. 0.68439. If I use my calculator, 1 minus 0.68439. In my calculator, I get 0.31561. In general, we round the answer to 4 decimal places. That's 0.3156. That's part B. The probability that 7 green marble, with more than 9 red marbles. That's part B. Part C. When 2 marbles are randomly chosen, assume the chance of choosing marbles from each box is the same. What's the probability that their total weight is less than 19 grams? When 2 marbles are randomly chosen, what's the probability that their total weight is less than 19 grams? Here, when we choose 2 marbles, there are 3 possibilities. We may get 2 red marbles, or 2 green marbles, or 1 red, 1 green marbles. There are 3 possibilities when we choose 2 marbles. So let's set down the problem first. Part C. The RR represents the event that the GG represents the event that 2 green marbles are chosen. The GR represents the event that 1 green marble and 1 red marble are chosen. the RR represents the event that two red marbles are chosen. Assume the chance of choosing marbles from each box is the same. What's the probability of getting two green marbles? For the first marble, I can choose it from either boxes. Same thing for the second marble. So for each marble, we have two choices. Denominator is 2 squared. For each marble, the chance of getting green marble is 1, and we are getting two green marbles with 1 squared. Probability is always number of viewable outcome over all possible outcome. That's 1/4. What's the probability of getting a red marble or green marble? Denominator is 2 squared. Numerator. Green marble or red marble. We make it a green marble first, and then get a red marble. Or we make it a red marble first, and then green marble. That's 1/2. We make it a red marble first, then green marble. Or green marble first, then red marble. So there are two different orders. 2 times 1 squared over 2 squared, that's 1/2. What's the probability of getting two red marbles? Denominator is 2 squared. Numerator, the chance of getting red marble is 1. There's only one way to get red marble, and we're getting red marble twice. That's 1/4. Next, let W be the event that the total weight of the marbles is less than 19 grams. Let W be the event that the total weight of the marbles is less than 19 grams. The total weight of the chosen marble. The total weight of the chosen marbles is less than 19 grams. We are looking for the probability. We are looking for the probability that the total weight of the chosen marble is less than 19 grams. That's what we are looking for. Since there are 3 different cases, here we can use the law of total probabilities. That's probability that it's possible that we get 2 green marbles and then their weight is less than 19. Or it's possible that we get a green marble and a red marble and their weight is less than 19. Or it's possible that we get 2 red marbles and their weight is less than 19. Then use multiplication rule. This probability can be rewritten as probability of GG times probability of W given GG plus probability of GR times probability of W given GR plus W of RR times probability of W given RR. We know probability of GG, probability of GR, and probability of RR. What we are looking for is these 3 conditional probabilities. What we need to find is these three conditional probabilities. For each of them, plug in here, we can find probability of W. Let's first of all find probability of W given GG. What's the probability of W given GG? If we choose two green marbles, what's the probability that their weight is less than 19 grams? If we choose two green marbles, what's the probability that their weight is less than 19 grams? So we are looking for probability of two green marble, the weight of two green marble is less than 19 grams. That's the probability that the two green marble, the weight of two green marble is less than 19 grams. Here we let x equal to G1 plus G2. The s equal to G1 plus G2. Since x is a linear combination of two normal random variables, x also has normal distribution. In order to find probability that x less than 19, we try to convert x to the standard normal distribution. Then we can use the table of the standard normal CTF to find probabilities. Let's first of all find its special value and variance of x first. mu of x is its special value of x. That's its special value of G1 plus its special value of G2. Its special value of G is 10. So we get 10 plus 10, which is 20. Next, we try to find variance of x. Variance of x is variance of S1, variance of G1 plus variance of G2. Variance of G is 1.2 square. So I get 1.2 squared plus 1.2 squared. If I use my calculator, 1.2 squared plus 1.2 squared is 2.88. Variance of x is 2.88. Then for sigma of x, I take square root for the variance of x. I get square root of 2.88. Next, convert x to z. Convert x to the standard normal distribution. Use x minus mu over sigma. The formula is x minus mu over sigma. Then use calculator, round the answer to 2 decimal places. Use calculator, round the answer to 2 decimal places. Here I get 0.59. This is phi of negative 0.59. This is phi of negative 0.59. Then use the table of the standard normal CTF to find the probability. Here is the table for negative 0.59. 0.5 is here, 9 is here. 0.59 is 0.27760. 0.27760. 0.27760. That's the probability that W given GG. If we are choosing two green marble, the probability that the weight of the marbles, the total probability that the weight of the total weight of the marbles is less than 19 grams. Next, for the second conditional probability, W given GR. If we have a green marble and a red marble, what's the probability that their weight is less than 19 grams? Next, we are looking for the probability that W given GR. If we have a green marble and a red marble, what's the probability that their weight is less than 19 grams? That's the probability that a green marble plus a red marble is less than 19 grams. The weight of a green marble plus the weight of a red marble is less than 19 grams. Here I let x equal to g plus r. Let x equal to g plus r. Since x is the linear combination of two normal random variables, x also has normal distribution. So this is probability that x is less than 19. Since x has a normal distribution, we can convert x to z, convert x to the standard normal distribution, then use the table of the standard normal CDF to find probabilities. Let's find mu of x and variance of mu of x and sigma of x first. For mu of x, let's expect derivative of x. Let's expect derivative of g plus expect derivative of r. Expect derivative of g is 10. Expect derivative of r is a. 10 plus a is 18. Next, we try to find variance of x. Variance of x is variance of g plus variance of r. Variance of g is 1.2 square. Variance of r is 0.9 square. So I get 1.2 square plus 0.9 square. Here I use my calculator. I get 2.25. Then for sigma of x, I take square root for variance of x. That's square root of 2.25. 2.25 is a perfect square. I get 1.5. Then once I know mu of x and sigma of x, I can convert x to z. Convert x to the standard normal distribution. That's the probability that z is less than 19 minus mu of x over sigma of x. Then use calculator. Round the answer to 2 decimal places. I get 0.67. Probability that z is less than 0.67. That's phi of 0.67. Then use calculator. Phi of 0.67. 0.6 is here, 7 is here. 0.67 is 0.74857. 0.74857. That's the probability that the total weight of the marble is less than 19 grams if we have a green marble and a red marble. That's the second conditional probability. Next, let's find the third conditional probability. Probability of W given RR. If we are getting 2 red marble, what's the probability that their total weight is less than 19 grams? If we are getting 2 red marbles, what's the probability that their total weight is less than 19 grams? That's the probability that R1 plus R2 is less than 19. That's the probability that R1 plus R2 is less than 19. So here, let x equal to R1 plus R2. Then since x is a linear combination of normal random variables, x also has normal distribution. Since x has normal distribution, I can convert x to the standard normal distribution, then use the standard normal CDF to find probabilities here. In order to convert x to standard normal distribution, we must first of all find mu of x and sigma of x first. For mu of x, let's expect derivative of x, which is expect derivative of R1 plus expect derivative of R2. Expect derivative of R1, expect derivative of R is A. So I get A plus A, which is 16. So mu of x is 16. Next, we try to find variance of x. Variance of x is variance of R1 plus variance of R2 variance of R is 0.9 squared. So I got 0.9 squared plus 0.9 squared. Here I use my calculator. I get 1.62. That's variance of x. Next, for sigma of x, take square root for variance of x. Take square root for variance of x. I get square root of 1.62. Then here I can convert x to z, to the standard normal distribution. The formula is x minus mu over sigma. X minus mu over sigma. Then use calculator. Round the answer to 2 decimal place. Round the answer to 2 decimal place. I get 2.36. This is phi of 2.36. Probability that z is less than 2.36. That's phi of 2.36. Phi of 2.36. Use table. Phi of 2.36 is 0.99086. 0.99086. That's the probability that if we are getting 2 red marbles, their total weight is less than 19 grams. That's the third conditional probability. Now we know all probability here. We can plug in the numbers for the probabilities. Probability of W equal to probability of GG times probability of W given GG plus probability of GR times probability of W given GR plus probability of RR times probability of W given RR. Then plug in numbers. Probability of GG is 1 over 4. Probability of W given GG is 0.27760. Probability of GR is 1 over 2. Probability of W given GR is 0.74857. Probability of RR is 1 over 4. Probability of W given RR is 0.99086. Then use calculator. Use calculator. Here I get, and round to 4 decimal places, I get 0.6914. Here use calculator. Round the answer to 4 decimal places, I get 0.6914. That's part C. That's the probability that the sum of 2 marbles is less than 19 grams. That's part C. Part D. When 2 marbles are randomly chosen, if it's known that their total weight is less than 19 grams, what's the probability that the chosen marble are both red? If it's known that their total weight is less than 19 grams, what's the probability that the chosen marble are both red marbles? This is conditional probability. That's probability of red intersection W over probability of W. The numerator can be rewritten as probability of red times probability of W given red over probability of W. Then plug in numbers. Probability of RR is 1 over 4. Probability of W given RR is 0.99080. Probability of W is 0.6914. Then use calculator, round to 4 decimal places. Here I get 0.3583. Number 8. In a hardware store, a certain type of primary battery has an average lifetime of 6 hours. John bought a total of 400 of these type of batteries from the hardware store. Part A. What's the probability that these batteries can be used for at least 105 days? Assume John only uses one battery at a time, and the batteries are used continuously. Part B. What's the probability that their average lifetime is less than 5.5 hours? So for this problem, let's set it up first. In this problem, we know that for a certain type of primary battery, their average lifetime is about 6 hours. If we know the average waiting time for occurrence of an event, we can use exponential distribution. So let the random variable x represent the lifetime of a battery. Of this type. Then we know x has an exponential distribution. With theta equal to 6, because we know that on average, we wait for 6 hours for using up of a battery. So theta is 6. Next, we try to find expected value of x and variance of x. Since x has an exponential distribution, expected value of x is theta, which is 6. Variance of x is theta squared, which is 36. So first step, we find the expected value of x and the variance of x. This is capital X. In this problem, we are looking for the probability that these batteries, these 400 batteries, can be used for at least 105 days. We are looking for the total lifetime of these 400 batteries. So let Y equal to the total lifetime of these batteries. So Y equal to the lifetime of the first battery plus the lifetime of the second battery plus the lifetime of every batteries. Then by central limit theorem, since Y is the sum of 400 independent, identically distributed random variables, Y has a normal distribution. Next, we try to find expected value and variance of Y. By central limit theorem, expected value of Y is n times expected value of x, where n is 400, because there are 400 independent, identically distributed random variables. N is 400. Expected value here is 6. Expected value of x is 6. 400 times 6 is 2400. Next, we try to find variance of y. Variance of y by central limit theorem is n times variance of x. Here n is 400 because there are 400 independent, identically distributed random variables. N is 400. Variance of x is 36. 400 times 36 is 14,400. That's variance of y. Now next, we are looking for probability that the total lifetime is at least 105 days. We are looking for probability that the total lifetime y is more than 105 days. A day has 24 hours, so that's 105 times 24. Since y has a normal distribution by central limit theorem, since y has a normal distribution, y has approximately normal distribution, we can convert y to z, to the standard normal distribution. The conversion in general is z equal to x minus mu over sigma. So same thing works for y. It's y minus mu over sigma. Here, what's mu and sigma? Mu of y is the same as the expressive value of y, which is 2400. Sigma of y is the square root of the variance of y. Sigma of y is the square root of the variance of y. If I take square root for the variance of y, I get 120. Here, 105 times 24, I get 2520 minus mu of y is 2400 divided by sigma of y is 120. Then use calculator. I get z greater than 1. Round to 2 decimal places, that's 1.00. Round to 2 decimal places, that's 1.00. Then since we try to use the table of the standard normal distribution, I try to write the probability in the form of z less than some constant, or probability that z less or equal to some constant. They both equal to phi of z. So here I can use the complement. Probability that z is greater than 1.0 can be written as 1 minus probability that z is less or equal to 1.00. That's 1 minus phi of 1.00. Then use the table of the standard normal CDF. Phi of 1.00 is here. That's 0.84134. 0.84134. That's phi of 1. 0.84134. Next calculator, that's 0.15866. If I round the answer to 4 decimal places, I get 0.1587. That's the probability that this battery can be used for at least 105 days. That's part A. Part B. What's the probability that their average lifetime is less than 5.5 hours? So part B. Let S bar represent the average lifetime of its 400 batteries. Then by central limit theorem, expressive value of S bar is the same as expressive value of X, which equal to 6. Variance of S bar. By central limit theorem, variance of S bar is variance of X over N. Here, variance of X is 36. N is 400, since there are totally 400 batteries. If I simplify, that's 9 over 100. That's variance of S bar. Next, we can find mu of X, mu of S bar. Mu of S bar is the same as expressive value of S bar, which equal to 6. Sigma of S bar is square root of the variance of S bar. If I take square root for variance of S bar, I get 3 over 10. That's mu of S bar and sigma of S bar. We are looking for probability that the average lifetime is less than 5.5 hours. We're looking for probability that the average lifetime is less than 5.5. By central limit theorem, the average lifetime of these 400 batteries has approximately a normal distribution. Then I can convert this to standard normal distribution, Z. Convert S bar to Z, the standard normal distribution. The formula for conversion is x minus mu over sigma The same thing works for S bar. So S bar minus mu over sigma. 3 over 10 is 0.3. Let's probability that z is less than. Here I use my calculator. Round to 2 decimal places. That's negative 1.67. Let's probability that z is less than negative 1.67. That's the same as phi of negative 1.67. That's phi of negative 1.67. Then use the table of the standard normal distribution. Negative 1.67, negative 1.67 somewhere here. It's 0.04746, 0.04746. If we round the answer to 4 decimal places, that's about 0.0475. That's the probability that the average lifetime of these 400 batteries is less than 5.5 hours. Number 9. In a country, 20% of adults are farmers. When 3,000 adults in the country are randomly surveyed, find each of the following probabilities using normal approximation with continuity correction. Part A. What's the probability that more than 640 adults are farmers? Part B. What's the probability that the number of farmers are between 550 and 570 inclusive? Let's set out the problem first. In a country, 20% of adults are farmers. When 3,000 adults are randomly surveyed, we can consider there are 3,000 Bernoulli trials, and the chance of getting a farmer is 20%. So the chance of getting success is 20%. We can consider this is a binomial distribution. We can consider this is a binomial distribution. So let the random variable x represent the number of farmers the number of surveyed farmers. Then x has a binomial distribution. With n equal to 3,000. P equal to 20%, which is 0.2. Next, we can find the expected value and variance of x. Expected value of x is n times p. 3,000 times 0.2. That's 600. Next, we can find the variance of x. Variance of x is n times p times 1 minus p. That's 3,000 times 0.2 times 1 minus 0.2 is 0.8. Three thousand times 0.2 times 0.8 is 480. That's variance of x. Here we can find mu of x. Mu of x is expected value of x, which is 600. Sigma is square root of variance of x. That's square root of 480. That's sigma. That's mu and sigma. Now, part A. Let's just set up part A. What's the probability that more than 640 adults are farmers? We're looking for probability that x is greater than 640. If we try to use binomial distribution directly, it may be too many cases. X could be 641, 642, 643 until 3000. So here we try to use normal approximation with continuity collection. In the probability histogram, 400 is somewhere here. 640 somewhere here. In the probability histogram, 640 is here. In the front, we have 639. After 640, we have 641, 642, and so on. We're looking for probability that S is greater than 640, means we don't include 640. So start from 641, 642 until 3000. Here the endpoint here is somewhere between 640 and 641. Here we use the midpoint. It should be 640.5. So if I use continuity correction, that's probability that X is greater than 640.5. If I use normal approximation with continuity correction, that's 640.5. Next, we can convert X to Z to the standard normal distribution. Let's convert X to Z to the standard normal distribution. That's probability that Z is greater than, conversion from X to Z is X minus mu over sigma. So I have 640.5 minus mu over sigma. Sigma is radical 480. Then use calculator. Round the answer to 2 decimal places. Use calculator. Round the answer to two decimal places. I get 1.85. Since I try to use the table of the standard normal CDF, I try to run the probability in the form of probability that Z is less than some constant, or probability that Z is less or equal to some constant. They both equal to phi of Z. They both equal to phi of Z. Since we are using the table of the standard normal CDF, here we can use the complement. That's 1 minus probability that Z is less or equal to 1.85. That's 1 minus phi of 1.85. Then use the table. Phi of 1.85. In the table, phi of 1.85 is 0.96784. 0.96784. So phi of 1.85 is 0.96784. Then subtract 1 minus 0.96784 is 0.03216. If we want to answer to 4 decimal places, that's 0.0322. That's the probability that there are more than 640 adults. There are more than 640 farmers. Part B. What's the probability that the number of farmers are between 450 and 470 inclusive? So part B, we're looking for probability that the number of farmers is between 550 and 570 inclusive. If we try to use normal approximation, we need to use continuity correction here. For continuity correction, let's draw the probability histogram. Let's draw probability histogram. 549 is here. Next one is 550. Next one 551. Next one 568. 569. 570. 571. We are looking for probability that S is between 550 and 570 inclusive. That means I include 550 and 570. We're looking for everything in between 550 and 570s. And we include the endpoint. We include 550 and 570. endpoint here should be the number between 549 and 550, which is 549.5 on the left, and the number between 570 and 571 should be 570.5 on the right side. So if I use normal approximation with continuity correction, S is between 549.5 and 570.5. Next, convert X to Z. Since I use normal approximation, convert X to the standard normal distribution. Convert X to the standard normal distribution. The conversion formula is X minus mu over sigma. 549.5 minus mu. Mu is 600 over sigma. Sigma is radical 480. X minus mu. Mu is 600 over sigma. Sigma is radical 480. Then use calculator. Round to 2 decimal places. Round the answer to 2 decimal places. Here I get negative 2.30 and negative 1.35. Next, in order to use the table of the standard normal CDF, I must find the probability in the form of probability that Z less than some constant or probability that Z less than or equal to some constant. They are both equal to phi of Z. So this probability here can be rewritten as probability that Z is less than negative 1.35 minus probability that Z is less or equal to negative 2.30. That's phi of negative 1.35 minus phi of negative 2.30. Then use the table. Use the table of the standard normal CDF. Phi of negative 1.35 is here. 1.35 is 0.08851. 0.08851. Minus phi of negative 2.30. Phi of negative 2.30 is here. Negative 2.30 is here. I get 0.01072. 0.01072. That's a check. Here I use my calculator. I get 0.07779. If I run the answer to 4 decimal places, that's about 0.0778. That's the probability that the number of farmers is between 550 and 570 inclusive. Number 10. In a restaurant, the average number of visiting customers is about 400 per day. Find each of the following probabilities using normal approximation with continuity correction. Part A. In a given day, what's the probability that the number of visiting customers is between 405 and 435 exclusive? Part B. In a given day, what's the probability that there are fewer than 370 visiting customers? So for number 10, let's set out a problem first. In a restaurant, we know that the average number of visiting customers is about 400 per day. That means in a fixed time interval, the event occurs, on average, the event occurs 400 times. In a fixed time interval, the event occurs, on average, the event occurs 400 times. If we know the average number of occurrence of an event, we can use Poisson distribution. So here, let the London variable x represent the number of visiting customers in a given day. Let the random variable x represent the number of visiting customers in a given day. Then x has a Poisson distribution. X has a Poisson distribution with lambda equal to 400. On average, there are 400 visiting customers, so lambda is 400. Next, we try to find expected value of lambda and the variance of expected value of x and the variance of x. Expected value of x for Poisson distribution, expected value of x is lambda, which is equal to 400. And for Poisson distribution, variance of x is also lambda, that's also 400. Next, we find mu of x. Mu of x is the same as expected value of x, which is 400. And then for sigma of x is variance of x. It's square root of 400, which is 20. Next, let's solve the problem. Part A. In a given day, what's the probability that the number of visiting customers is between 405 and 335 exclusive? So we're looking for probability that the number of visiting customers is between 405 and 435 exclusive. Next, we try to use normal approximation with continuity correction. Let's draw a probability histogram first. Assume 405 is here. Next is 406. Next is 407, and so on. 433, 434, 435. Since we don't include the endpoint, we don't include 405 and 435, we're looking for probability from 406 to 434. Since we don't include 405 and 435, we're looking for probability that S between 406 and 434. So the endpoint is here. Here, left endpoint is between 405 and 406. That's 405.5. Right endpoint is between 434 and 435, which is 434.5. So, if I use normal distribution with continuity correction, S is between 405.5 and 434.5. Then we can convert x to the standard normal distribution. Convert x to z, the standard normal distribution. The formula for conversion is x minus mu over sigma. So 405.5 minus mu. Mu is 400. Over sigma. Sigma is 20. Then take 434.5 minus mu. Mu is 400. Over sigma. Sigma is 20. Then use calculator. Round to 2 decimal places. Use calculator. Round to 2 decimal places. Here I get 0.28 and 1.73. Use calculator. Round to 2 decimal places. Next, we try to run a probability in the form of probability that z is less than constant or probability that z is less or equal to some constant. And they both equal to phi of z. That can be rewritten as probability that z is less than 1.73 minus probability that z is less or equal to 0.28. Probability that z is less than 1.73 is phi of 1.73. Probability that z is less or equal to 0.28 is phi of 0.28. Then use the table. Phi of 1.73 is 0.95728. 0.95728. Phi of 0.28. Phi of 0.28 is 0.61026. 0.61026. Then use calculator. Subtract the numbers. Use calculator. I get 0.34792. Then round to 4 decimal places. In general, round answer to 4 decimal places. That's 0.3479. That's part A. The probability that the number of visiting customers is between 405 and 435 exclusive. Part B. In a given day, what's the probability that there are fewer than 370 visiting customers? So for part B, we're looking for probability that x is less than 370. In order to use normal approximation with continuity correction, let's draw the probability histogram first. A rough probability histogram looks like this. X is less than 370. Start from 0, we have 368, 369, 370. We're looking for probability that x is less than 370. Means we don't include 370. We include everything less than 370 until 368, 369. The endpoint is here. The endpoint is here. That's somewhere between 369 and 370. That's probability that x is less than 369.5. If I use normal approximation with continuity correction, then I can convert x to z. Next, convert x to z. That's probability that z is less than. The formula for conversion is x minus mu over sigma. 369.5 minus mu. Here mu is 400 over sigma. Here sigma is 20. Then use calculator, round to 2 decimal places. Use calculator, round to 2 decimal places. I get negative 1.53. That's phi of negative 1.53. That's phi of negative 1.53. Phi of negative 1.53. Use a table. Phi of negative 1.53. I get 0.06301. 0.06301. In general, round answer to 4 decimal places. That's about 0.0630. That's a probability that in a given day, the number of visiting customers is less than 370.